Within recent years, most of us can remember energy shortages, long lines at gas stations, and presidents urging us to turn down our thermostats. OPEC seemed to have us in a stranglehold as they limited our supplies in order to demand more dollars for fuel. Then we countered with increased domestic production and cars that offered better mileage. OPEC began fighting among themselves, and for a while fuel prices headed downward. Although fuel prices may rise and fall in the short run, the long-term trend is up. And it is in our national interest to rely less on foreign oil and to economize our use of fuel so that generations to come will have vital energy supplies. For these reasons, it makes sense to minimize your fuel consumption. You'll save money and you'll conserve our natural resources. Although saving fuel and conserving energy are important goals, the words you see on the front of this bulletin that read, "Our business is saving fuel," are not something that was printed there a short time ago. Fuel Efficiency Incorporated has been in the business of saving fuel ever since Walter Brock invented the Turbulator during World War II. In the next few minutes, you'll learn how you may save 6 to 16% of your annual fuel consumption, and of course, save 6 to 16% of your annual fuel cost as well. Regardless of what business or industry you're in, if you are using gas, oil, or a combination gas-oil fire tube or cast iron sectional boiler to produce heat or power, you can save at least 6%, perhaps as much as 20%. These figures may sound a little far-fetched to you. Certainly you have a right to be skeptical because there are so many fuel-saving devices on the market today, and many of them simply cannot prove their worth. We can. For example, here are a few of many verified fuel savings reports we have in our files. They compare fuel consumption before and after installation of Brock Fuel Saver turbulators and ensure that the savings were real and verifiable. The reports make the comparison on a degree-day basis and eliminate any savings that might have resulted from milder weather. Here are just a few quotes from these fuel-saving reports. The job cost us $400 and paid for itself in the first 7 or 8 weeks. Our gas bills run $1,500 to $1,600 a month, so the savings created by the Brock turbulators amounts to 14 to 15%. Dwight Alma Dairy Products, Incorporated, Alma, Kansas. The installation of Brock Fuel Saver turbulators has resulted in a 3.4% increase in combustion efficiency in our cast iron sectional boilers and a decrease in stack gas temperatures that averaged 86 degrees Fahrenheit. George Woolridge, Central Bucks, PA School District. The turbulators have paid for themselves many times over. There have been no complications or undesirable side effects caused by their use. You may count the Buffalo Municipal Housing Authority as a well-satisfied customer. Buffalo Municipal Housing Authority, Buffalo, New York. Our experience shows that, on the average, as a result of using Brock Fuel Saver turbulators, schools are cutting their fuel bills by 12%. Industrial plants by 8%. Greenhouses by 16%. Apartments and condominiums by 9%. Hospitals by 11%. Hotels and motels, 11%. And stores by 13%. In fact, every category of commercial, industrial, and institutional building using Brock turbulators has experienced a significant savings. For years, Fuel Efficiency has offered this guarantee to customers who are willing to make a valid degree-day comparison. If Brock turbulators don't reduce fuel consumption by at least 6%, we'll remove the product from the customer's boiler and make a full refund for the cost of the product. Some people say, "Sure, I suppose it's possible to cut my fuel consumption by installing turbulators. But couldn't I get the same results by adjusting my burner so that the fuel-air mixture is optimum?" The answer is no. The savings from turbulators are in addition to savings resulting from burner adjustment. When we install turbulators, we adjust the burners too. And if a burner is badly out of adjustment, we find that we can frequently reduce fuel consumption by as much as 20%. But even if the burner is adjusted to perfection, we can still save 6 to 16% of the fuel. Perhaps a simple demonstration, the way our dealers perform it, will help you understand how.
This is an ordinary piece of boiler tube with nothing in it. I'm going to light this propane torch and place it in the end of this tube. Now I'm going to take an ordinary piece of notebook paper and wrap it around the tube. Nothing happens. But when I hold this same piece of paper at the end of the tube, within a few seconds, it bursts into flame. Why? It's because the hot gases are flowing out the tube, but very little heat is being conducted through the tube. As you'll see here, this thermometer shows that the gases leaving the tube have a temperature of 830 degrees. In a boiler, this means there's a tendency for too little heat to be transferred through the tube to heat the surrounding water, and a tendency for too much heat to pass out the tube and up the stack where it's wasted. Now I'm going to insert this turbulator into the fire tube. Let's try the same experiment. When I hold the sheet of paper at the end of the tube, nothing happens. But when I wrap this same sheet of paper around the tube, it scorches within a few seconds. Checking the thermometer, you see that the gases passing out the tube aren't nearly as hot, only 460 degrees with the turbulator compared to 830 degrees without. This shows there is a way to reduce the heat being lost up the chimney and put that same heat to work by using it to make hot water or steam in the boiler.
And that's how turbulators are demonstrated. Actually, there is a scientific explanation for this. As the fuel-air mixture combusts, the gases expand to perhaps 5 times their original volume. These hot gases are turbulent as they enter the tubes, and they give off heat freely. But as these gases cool, they contract. They no longer fill the fire tubes. They lose their turbulence, draw away from the tube walls, and slide forward in a straight line flow. Between this hot inner core and the walls of the tube, there's an insulating layer of cooler gas. These hot gases sliding through the tubes in a straight line flow go up the stack as wasted heat. This is a Brock fuel saver turbulator. To the casual observer, it may look like a funny-shaped piece of metal. A major gas utility once ran an ad in Time magazine describing it as a crooked way to cut fuel bills. It's crooked only in shape. There's nothing illegal in using it. In contrast, a turbulator in the same tube breaks up the hot center core, recreates lost turbulence, and scrubs away the barrier of cooler gases. And the heat that formerly was wasted up the stack is now available to heat the surrounding water. This very briefly explains how, with turbulators, you can reduce fuel consumption by increasing the thermal efficiency of your boilers. Earlier, it was said that when combined with proper burner adjustment, these savings could run as high as 20%. Burner adjustment is important, and it is one of the services dealers perform when they install turbulators. Let's examine why burner adjustment is so important in cutting your heating bills. Each fuel has a characteristic temperature at which it burns. This is called its flame temperature. For natural gas, the flame temperature is 3,450 degrees Fahrenheit. For number 2 fuel oil, it's 3,540 degrees Fahrenheit. And for number 6 oil, it's 3,620 degrees Fahrenheit. In a laboratory, using a Bunsen burner, it is possible to adjust the gas-air mixture so that the balance is nearly perfect, and you can get close to 3,450 degrees Fahrenheit at this point. But in a boiler, conditions are not perfect. Take draft, for instance. The chimney will pull more on a clear, windy day than on a balmy day. In the combustion chamber, the gas and air may not have a chance to mix thoroughly and burn. So, in order to ensure complete combustion, 20 to 30% excess air is usually added. This excess air dilutes the flame temperature down to 2,700 degrees Fahrenheit, a good workable standard. However, in actual practice, our installers find that many burners are poorly adjusted and are firing at 1,600 to 1,900 degrees Fahrenheit. Temperatures this low in the combustion chamber indicate there's too much air in relation to the amount of fuel. Or, to put it simply, the flame is being air-cooled just to make sure the gases are burned. As the fuel burns, carbon dioxide is formed. In fact, if one measures the percent of carbon dioxide present in the combustion chamber, he can accurately predict the flame temperature. If the percentage of carbon dioxide is low, he knows there is excess air that is cooling the flame temperature. In other words, as the percentage of carbon dioxide goes down, the flame temperature goes down. When our dealer installs turbulators, he checks the carbon dioxide content of the stack gases. Then he adjusts the burner to give you the correct carbon dioxide balance for the type of fuel you are using. Turbulators help you get the proper carbon dioxide balance, achieve higher temperatures in the combustion chamber, and reduce the need for excess air in order to achieve complete combustion. The undesirable air cooling effect is minimized. This cross-sectional view of a boiler without turbulators will help you to understand how this happens. Let's assume the burner is properly adjusted and that the temperature in the combustion chamber is 2,700 degrees. As the gases burn, they are turbulent, but because they are hot, they rise rapidly, filling the top and center tubes, scanting the lower tubes. In the fire tubes, the gases form the characteristic hot inner cores. The heat is unequally distributed through the tubes. The temperatures in the top tubes may be 800 degrees or more, and the lower tubes may be as little as 400 degrees. The stack temperature may average 600 degrees as shown here, or even hotter. Here is the same boiler with Brock Fuel Saver turbulators. Notice that the combustion chamber and rear turnaround section are more completely filled with hot gases. There's more turbulence, and the hot gases are in intimate contact with the walls of the fire tubes. All the tubes from top to bottom now carry equal heat. All do equal work. Heating surfaces are utilized more efficiently. Also notice that the stack temperature is only 400 degrees compared to 600 degrees in the previous illustration. This means that less heat is being wasted up the chimney. When turbulators are installed in your boiler, you'll know they're doing their job because the changes can be measured quickly. You'll notice a decrease in stack gas temperature. You'll notice an increase in CO2, indicating a higher flame temperature. You'll notice an increase in boiler capacity, or what's more important to most, a decrease in fuel consumption. It's only natural that people want to know whether turbulators cause any maintenance problems in boilers. For instance, they ask, do turbulators cause boilers to soot up more than normal? The answer? An emphatic no. You see, soot is caused by the incomplete combustion of the fuel. Turbulators help to make combustion complete by stabilizing the draft. Often, users tell us, hey, we only had to clean our boiler once this year. Before the turbulators, we had to clean our boiler 2 or 3 times. Savings like these, in labor and convenience, are typical. When cleaning a boiler, the turbulators are easily removed and easily reinserted after cleaning. Another natural concern is, can turbulators in any way damage my boiler? Again, an emphatic no. Turbulators tend to increase boiler life because they spread the heat more evenly through the tubes, eliminating hot and cool spots, balancing the load on the fire tubes, and decreasing thermal stress. In the history of fuel efficiency, there have been no boiler failures due to the installation of turbulators. And if for any reason a boiler should overheat, the turbulators would simply flatten out in the tubes, so the added heat transfer stops before damage can occur. Before installing turbulators, the dealer will make 3 important tests of your boiler: draft, CO2 reading, and stack temperature. These tests take less than 20 minutes and will not harm the boiler. But they are essential if the installation of turbulators is to save you as much fuel as possible. You might compare these 3 tests to your doctor's checking your pulse, heartbeat, and blood pressure. A small hole will be drilled into the stack, and a CO2 analyzer will be inserted. This will indicate the air-fuel ratio. Too much air is wasteful because it cools the entire boiler system and performs no work. Next, using a draft gauge, the dealer will check the overfire draft. Excessive draft is wasteful. Zero smoke on gas or light oil is a must. The lighter the smoke on heavy oil, the better. With gas, no carbon monoxide is acceptable. With non-pressurized burner equipment, some overfire draft is a must. Finally, the installer will insert a long-stemmed thermometer and measure the stack temperature. This indicates how well the boiler is absorbing available heat. These 3 simple tests enable him to install the turbulators properly and give you assurance that your boiler will be operating at peak efficiency and decreasing your fuel consumption by at least 6% and possibly as high as 20%. When fuel efficiency tells of savings of that magnitude, people often think turbulators must be costly. Actually, they're not. The cost will vary depending on the number and size of the fire tubes in the boiler, but the cost is amazingly low. In fact, fuel savings during the first heating season usually more than pay for the cost of the turbulators. And since turbulators are expected to last as long as your boiler, the savings keep accumulating year after year. As further proof that turbulators increase boiler efficiency, many of the nation's leading boiler manufacturers make turbulators available with new boilers they sell. In fact, turbulators are shown in some of their catalogs. To summarize what's been said in the last few minutes, you can reduce your fuel consumption and fuel costs by at least 6% by using turbulators. Savings of up to 16% are not unusual. Some have saved as much as 20% when the savings of turbulators are combined with those made possible through improved burner adjustment. Furthermore, fuel savings are guaranteed. There is no risk involved because turbulators tend to extend boiler life by minimizing thermal stress. Finally, turbulators tend to reduce maintenance and cleaning costs. Prove it to yourself by having your dealer install turbulators in your boiler. Then, after analyzing your own records, you'll see that these savings